It's easy to deploy a StreamNative BYOC cluster using the Ursa Engine from the StreamNative UI. We've already created our BYOC cloud connection and cloud environment, where StreamNative deploys the required infrastructure into your cloud provider. If you're unfamiliar with this process, see the video description for more information. Here we deploy a cluster using the Ursa Engine by selecting New or create a new instance and deploy a cluster. Select Deploy BYOC and provide your instance name. Here I've already created the BYOC cloud connection after providing StreamNative permissions into my cloud provider. I select the Ursa Engine, which uses Lakehouse-based cost-optimized storage. After selecting cluster location, provide the cluster name and select your cloud environment. Here I've again already created a cloud environment, with StreamNative reaching out to my cloud provider to deploy the required infrastructure. For this demonstration, I select Multi-AZ. Select Cluster Size, and notice that you have the option to adjust the size and number of brokers, but not bookies. The option to use bookies for latency-sensitive workloads will be enabled in a future release. Select Finish to deploy the Ursa Cluster, which will use Lakehouse-based cost-optimized storage. Once deployed, we can navigate to the cluster dashboard page. To get started publishing to the cluster using the Kafka protocol, navigate to Kafka Clients on the left pane. You can choose your client library, select a service account, select an authentication type, and enable schema registry. You'll be provided the required code to install needed client libraries and sample producer and consumer code pre-populated with the server's Kafka endpoint and security settings. Next, let's go through the process of what it looks like to migrate an application from a legacy Kafka cluster to this new Ursa cluster. Here I am in IntelliJ, and I already have a consumer connected to my legacy Kafka cluster. To show this working, I'll produce a few messages to that cluster. And on the left, you'll see it says Publish to Legacy Kafka Cluster. That's the message itself. And on the right, you can see the message is consumed, and it says Consumed by the Legacy Kafka Cluster. We already have UniLink running in the background, moving data from our legacy Kafka cluster into the new Ursa cluster that we just spun up. I'd like to start up a consumer that's pointing to the endpoint of our newly created Ursa cluster to show that the data has been migrated over. Once the Kafka consumer has started up, we'll see that the messages published to legacy Kafka cluster are consumed by our Ursa cluster. To show this in real time, let me go ahead and produce a few more messages to the legacy cluster, and you'll see them consumed on both the legacy cluster and the new Ursa cluster. That'll be here in the middle as consumed by the legacy cluster, and here on the right as consumed by the Ursa cluster. Once this is all up and running, we can now shut down our Kafka consumer and Kafka producer on the legacy cluster and just move our producer over to the new Ursa cluster. So here on the left, I'll produce some messages to our new Ursa cluster, and you'll see that they get consumed on our new Ursa cluster. So we've gone through the process of migrating historical data from the legacy cluster, as well as migrating our producer and consumers completely over to our new Ursa cluster. As a reminder, this is a BYOC cluster. So this is running inside of your cloud provider on your infrastructure. So here in the StreamNative UI, I can see the name of the cloud environment. If I head on over to my cloud provider account in AWS, I can see the cluster name. This is the EKS cluster where the Ursa cluster is running. But what I'm actually more interested in discussing today is the S3 buckets. You can see that there's two folders. One is storage folder where the Ursa streams data is stored. And there's also a compaction folder where if we go into the public default and then go ahead and find our test topic summit topic, you'll be able to see the Parquet files, where in this case we're stored in Delta Lake. To see how easy it is to access that data in S3, we're going to go ahead and use DuckDB to query that data. Here the delta path is a path to that S3 bucket. So if I go ahead and execute this, you'll be able to see that it returns the results. And we have both the messages that were migrated from the legacy Kafka cluster, as well as those messages that were produced directly into our Ursa cluster. In addition, let's head on over to Databricks. Here we have a table test topic summit that's pointing directly into our S3 bucket location, as you can see here. If I go over to sample data, you'll be able to again see that we're able to consume the data that was originally published to the legacy Kafka cluster and migrated to the Ursa cluster using UniLink, as well as any of the data that is now being produced directly to the Ursa cluster. We've gone through the process of spinning up a new BYOC Ursa cluster, migrating existing data from a legacy Kafka cluster into the Ursa cluster, as well as moving our producers and consumers over to the new cluster. And we've shown that the compacted data is readable by external applications such as DuckDB or Databricks.